Thank you. Very happy to be here today. So yes, my name's Elaine. I'm an architect. I'm at the Concrete Centre, and I'm going to, in this talk, bring us right down to detail. We've talked citywide. We've talked lots of fantastic initiatives, and I'm going to get stuck into actually building because that's what I'm into. That's what I'm interested in, and obviously the Concrete Centre. That's part of what we deal with. I thought I'd just introduce who the Concrete Centre are for those of you who probably don't know who we are. Some of you may do. We're the central technical and marketing hub for concrete in the UK. And so my colleagues, so I'm an architect, my colleagues are architects, structural engineers and building services engineers. And our remit is to give guidance to other professionals, to speak to other construction professionals that are helping them use concrete. So answering lots of questions, we produce a lot of guidance. Most of the stuff's all free and it's on the website. I've recently completed a document, Concrete Green, which the BRE are very helpful with helping us. And so lots of information that we try to provide out there, including Concrete Quarterly. Recent Sterling Prize winner on the front cover, quite excited about that. Good, robust school solution. Now, one of the publications we've produced is this one, Ahead of the Game, which is outside, and hopefully some of the publications we have brought with us today, but there are many, many more on our website, concretecentre.com. At EcoBuild earlier this year, one of our main themes over the 3 days was resilience, and we brought together a series of different speakers to talk about the subject, and within this document we've just collated some thoughts about best practice examples. It's an area that we recognise is of a growing consideration. It's new credits within BRE related to it. There's certainly issues in the new HQM standard for homes, Home Quality Mark standard, the BRE are developing. But before I go into the role of concrete within resilience, because actually concrete and masonry has a really key role to play within the built environment with regards to providing resilient solutions, I thought I'd just paint a little bit of a broader or put it into a broader context about concrete within a sustainable built environment, because fundamentally that's what we're talking about, isn't it? I mean, we're talking today mainly about flood issues, but it's all about, sustainable communities and sustainable environment. The industry are very committed to that, and their commitment was consolidated back in 2008, where pretty much most of the concrete and masonry material supply signed and committed to a construction concrete industry sustainability strategy, and that is about collating data. So much of it is about that, reporting that, providing transparent information, and reporting on a whole series of different sustainability issues. And this is just a summary of the new targets that were then set in 2020, and issues to do with providing life cycle assessment information, low carbon freight initiatives, a water strategy, water being the new carbon, of course, that's what we're thinking about. So if any of you are interested in that data, we produce it every year. We've got a copy of this outside the 7th industry report, and that's all available on the Sustainable Concrete website that's down there. And I thought I'd just share with you a few of the facts that come out of the headline facts, really, that come out of the last report. So, for example, concrete is locally and responsibly sourced. Hugely important issue when you're thinking about sustainability, and actually hugely important when you're thinking about resilience of materials and the ability for construction industry to be able to respond to issues of disaster even. Let alone just ordinary sustainable procurement. 91% of all concrete certified to BES 6001, which is the BRE's responsible sourcing accreditation. But people are aware in this room about what responsible sourcing is. It's a bit like fair trade, coffee and bananas, things like that, but for construction materials. So another one is net user of waste. An amazing figure that the industry as a whole uses 79 times more waste and recovered materials during the manufacturing process than it sends to landfill. And a lot of that is because of the amount of recycled content that's in the products, but also the use of alternative fuels in the making of cement. So brilliant figures that are coming out there. And I put this one in as well, because biodiversity, don't always think about that as sort of bedfellows with regards to concrete, but of course aggregates coming out of the ground, but hopefully maybe you're aware that actually the license to be able to extract is only for a short period of time, and what goes with that is the responsibility to put back the environment, actually in an enhanced state when you left it. There are, I think, nearly 700 sites of special scientific interest around the UK that are old quarries or excavation sites. A really fundamental part of that, and within the sort of quarrying part of the industry, and I didn't mention actually, we're part of MPA, which is the Mineral Products Association, which is the trade association for all that stuff that comes out of the ground. Biodiversity is a really important subject to them. There are annual awards. Take it very seriously. And then, of course, carbon, mustn't talk about that, must not forget to talk about that. It's certainly something that often people talk about with regards to concrete and say, oh, isn't it high in embodied CO2? Actually, well, what figures are you using? It's already 22% less as a baseline figure since it was in 1990, and the figure is to set that. That's just to reach 30% reduction by 2020. And I spend a lot of my time day to day actually giving guidance to designers about how they can improve on that figure even more by the choice of their specification and the types of cements that they use. So using low carbon concretes, but also in the use of their buildings to reduce the amount of energy that's used in the building, so operational CO2. Which brings me on to the key issue, which we're talking about today, is the inherent properties of the material. And concrete, this is one of the extract from that document I mentioned earlier. Concrete has, and masonry is inherently good as various different performances that perform well in terms of resilience. So fire, for example, it doesn't burn, it doesn't spread a flame, hugely important, and therefore then reinstatement is much easier after a building if there's been a fire, because it doesn't spread. Thermal mass, very important for reducing the amount of energy use in a building, particularly with keeping buildings cool, and therefore has a significant role to play as a solution for tackling the growing issues to do with overheating, and I'll talk about that a bit later on. Durability, acoustics, robustness and security, and flood resilience. So all of those things, holistic approach, and actually, of course, as an architect, I need to be thinking about all of those things when I'm designing a building. We're talking a lot about flooding today, but we need our buildings to respond to all the different aspects that we need to think about. So if we can get and choose through our choice of materials or choose the choice of the way that we build, something that is going to be tick a lot of those different boxes, that's really what we're aiming for. So as I said, concrete's got a significant role to play in dealing with flooding on every aspect. It's inherently resistant. It performs well in water. It's why we have concrete sea defences. It's why we have concrete footings and foundations. Concrete can be designed in various different ways and particularly improved to resist aggressive environments like seawater. And in fact, a very low carbon cement, particularly with GGBS, is very good at dealing with that. It's got a real role to play in the use for flood defences and in flood repair. So obviously, doorless rail repair was completed 2 weeks ahead of schedule, I think, but significantly using off-site precast concrete walls and retaining walls to be able to just brought in and craned in to be able to resolve those solutions. Now we know flood defence is only just one part of the whole discussion. We need to be looking at this as a macro down through to micro level. But of course then there are many different suds products out there that are made using concrete. You wouldn't necessarily make that analogy there, but of course lots of permeable paving. And in fact, not just permeable paving, but actually some solutions that have been around for quite a long time. And maybe we're not, grasscrete, for example. But also, and then new ones, such as permeable concrete. And that was mentioned earlier today. So this is a relatively new innovation. So it looks like concrete, I was said, but actually water just flows through. And I think there was the video mentioned earlier that's gone viral on Facebook and different places. We've actually got it. You can come and have a look at that on our on the stand outside. We've got it. We can put it up on the computer if you like to see it, where there's just gallons and gallons of water being dumped on the floor and it just disappearing as if by magic. It's quite extraordinary. So there's lots of innovation as well coming through for solutions to be able to help reduce the risk of flooding in and around a home. Even water harvesting, this was a scheme that was originally to be put in, and I don't know if it's still in here, but the Hanson House on the BRE Park actually was going to be using this system of actually using those pavings to be able to collect the water and then use it potentially as grey water. Green roofs have already been mentioned today, and of course concrete is a really good solution as a structural base to be able to put one of those green roofs on there. You'd want something that's inherently not going to be responsive to water, supporting all that stuff up there. But then what about actually the fabric of the building itself? So this is what I'm going to talk about now. Now, concrete in masonry maintains its structural integrity, when it's flooded and after it's flooded. It doesn't rot. It doesn't warp. So inherently, it's going to be maintaining that integrity. Really key aspect to the whole process. Now, it's pretty well established, the three-tier approach that has been around for quite a long time. Clearly, what one wants to do is try to avoid a flood in the first place, and we know that that's not always going to be possible. There's going to be some residual flooding. And the idea of resistance, which is the dry-proof or water exclusion, and then resilience for water entry, both of those dependent on how long the duration of the flood is and how deep it's going to be. I think what's beginning, and certainly I think what I would advocate, and it seems to be that the new British standard that's going to be coming out is advocating as well, is actually the merging of those two together is a sensible approach. It's not an exact science, is it, predicting floods? So actually if we can provide solutions that are going to enable us to provide some sort of solution to try to keep water out, but also if it does get in, it's not going to be limiting the amount of impact, then that's the way to go. Now, a few years ago, we produced some documents and some guidance that consolidated a lot of the best practice thinking about designing with concrete in masonry, using it in flooding construction. They're quite long in the tooth, these documents now, and I suspect we'll be revising them when the British Standard comes out, hopefully soon. But within there, I think one of the key things that I think is certainly worth thinking about is that if we get the bones and the structure right, so you've got making the right decisions and what's appropriate to whatever level of risk has been identified in that building, then there is always the ability to be able to then think about what future mitigation measures can be added on as and when they're required, if they're deemed to be. So you want to get the amount of it there. But I think the managed adaptation route is an important part to think about. And I think if you think about it early enough, recognise what a strategy might be. So, for example, on the outside, maybe in early deals you will put in stainless steel ties at the low level of the building. It may be that you're thinking about putting in engineering bricks just at the low level of the building because they're more resilient than a handmade brick to the effects of water. Or you think about, well, I'm not going to do that, but I know that at a later date, if things got really bad, that is a good, robust structure that I could then just render. That's all able to do that with the decisions that you've made at an early stage. And I think that's one of the ways to be thinking about how we do that. And the key thing is, it's not a million miles away from what we're already doing. And that's what I want to try to sort of illustrate. I think the way that we've been designing, and our designs have been evolving through thermal performance, as I mentioned in my question earlier, with just a little bit more tweaking in the same ways, we can be in building, and attention to details, we can be doing that. Now, solid wall construction is, by definition, a really good way to go when we're thinking about flood prevention. There's no cavities in there. It's not that common as a form of construction in the UK, but when I first started practicing, I was in Germany, a lot of this about. And there is a growing interest in this as a form of construction. It's a very simple way of providing air tightness and reducing thermal bridges. And in fact, the Code 6 house that's built on the BRE park is using this form of construction. And of course, it's robust, stops the water entry, there's no voids in there. The key issues with all of this, actually, it always comes down to insulation, doesn't it? So closed cell insulation, something's going to be able to be maintained there. Location of where the damp-proof course goes. Maybe we just need to be putting our damp-proof courses slightly higher up within our buildings than we do as a matter of course. Maybe that's one way of looking at it. Not very limited amount of on-cost associated with just tweaking how we do those things. Anybody aware of insulated concrete formwork as a construction system? This is something that's it's a growing part of the market, particularly within self-build as well. So this is just a very simple way of being able to provide in situ concrete, but using an insulation system so that they're stacked together, and that's a permanent mould, if you like, that you pour the concrete into. Often used for basements. It's a very good water weather-tight form of construction. And again, inherently strong and robust, its ability to be able to keep water out. And depending on where you put your membranes, to be able to for drying afterwards. Slightly more of a challenge with cavity wall construction, which is fundamentally what most of the things that we build within the UK. I think, did I mention that most housing within the UK at the moment is still, it's about 85 to 90% masonry is the way that we build these days, so blockwork and brick. It varies according to where you are in different regions within the UK, but I think it's the cavities are the ones that we need to be thinking about, and there's a lot of lessons to be learned from the retrofit market and things that can be done to buildings in terms of closing off weak holes and how we plug those at a later date. But I think, again, the New British Standards is talking about removing insulation in cavities. That's the right way to go. And yet, of course, you've got regulation on the other side saying we need a lot more insulation than we're currently doing. So there's going to need to be some joined-up thinking there. I think certainly, again, closed cell insulation as full fill, that's something not going to be moved. Maybe inspections, lots of things that we can think about. And I think there's certainly still a role to be had for the cavity wall construction, provided we think about the detailing. And actually what we shouldn't forget is that actually we're still just talking about the lower parts of the building. You know, it's not got to fundamentally change the way we do everything. We're really generally still talking about the lower parts. In terms of floors, of course, solid concrete ground floor is pretty much the principle for reinstatement of properties that have been flooded, and it's still depending on what the ground surface is, it's still one of the preferred options for construction. But of course, and it's not so brilliant if there's a ground swell with water coming up through the ground. But of course, that's when maybe the cavity, so a raised floor, which is actually at the moment where most mass house builders use as a floor construction. So there's a void underneath. The key issue there is just making sure that that void is then accessible to be able to clear any debris if and when it came through. So there's a few other detailing considerations which I don't think this is the audience to go through. This is a sort of training that I give when I'm talking to architects and saying things like, as I said, stainless steel, wall ties, consideration of quality of workmanship and detailing. All of these are under scrutiny anyway within the industry. There's the whole issue of performance gap. We're all improving air tightness and thermal performance. You know, adding flood resilience to that menu of things to think about is absolutely achievable. And of course, resilience is not just about what you're making your building out from a fabric point of view. It's about many other things, and I think it was mentioned earlier today. You know, there's a well-known image from the Environment Agency. You know, where the electrics go, putting them in at a higher level, making sure that you've got the right sort of fittings, whether they are sacrificial, or actually using, you know, non-fitted carpets and using hard surfaces on the ground. And this immediately sparks an interest for me as an architect. So I'm like, yes, I can do more with that. There's a great synergy there with thermal mass. You know, if you've got hard surfaces, underfloor heating, which is a closed unit, so that's not going to be affected by the flooding. You know, tiles, that's a really good, efficient way of putting in low-level energy into a building, but also is a means of being able to then keep the building cool. And that comes on to thinking about how we need to make our buildings meet lots of different requirements. And we know that there are growing issues with regards to overheating. In new houses in particular, and existing ones, we know that temperatures are rising. We don't want to be getting into the fact that people can't afford to be able to put on air conditioning in the summer. And thermal mass is recognised in lots of different reports have been going through. Zero Carbon Hub have done a lot of work on this, NHBC Foundation. And thermal mass with ventilation is a recognised means of being able to keep buildings cool in the summer as well. So this is where some of the thoughts of being able to resolve one aspect of resilience can help resolve some others. And then, well, how does that work? Well, I just think back to those sunny days down in the south of France, fundamentally Mediterranean-style housing, often with solid floors, you know, massive walls, shading that's enabled us to, you know, environments where people are used to trying to keep the sun out and being able to keep themselves cool using shutters. And there's that drive, the concrete and masonry is very high in thermal mass. The key thing is just getting the insulation on the outside. And then you're being able to use the fabric of the building to be able to help reduce the amount of energy that's used either for heating or cooling. Now, Sometimes I could spend a whole hour just talking about how you use thermal mass and how you design for it, and I'm not going to go through that today. We haven't got any of these documents with us today. I have one of them, but we've got a really good one called Thermal Mass Explained, which is free to download from our documents. If that's something you're interested in, by all means, have a look at that or ask me afterwards. I can tell you a bit more about it. But it's a recognised means of keeping our buildings cool. It's the reason why, and if ever you've wondered going into any of the new schools that have been built, why there's a lot of exposed concrete around. It might be painted, you might not even notice. Concrete on the inside can help keep buildings cool. It's not just structure, it can provide all of those different aspects in terms of low maintenance, fire resistance and thermal mass. So it's single solutions that are able to meet various different aspects of fire resistance, and it's not a huge leap of faith to recognise that we can do that fairly simply with the way that we're actually already building. That's it. Thank you very much.